Hi, my name is Hasraf Shafiq Ben Hayran and my matrix number is 2024268894.
Hello, my name is Muhammad Mawal bin Muhammad Fakhr Rizal. My matrix number is 2024296104.
Hi, my name is Wan Muhammad Amar bin Wan Zainal. My matrix number is 2024662528.
My name is Haziq Izak bin Azman and my matric number is 2024404076.
My name is Muhammad Zagil Shaufi bin Supari, matrix number 2024251606.
Assalamualaikum. Today, my group will present our assignment on noise pollution measurement using a sound level meter SLM. Noise pollution is an unwanted sound that can affect people's health and daily activities. Common sources of noise included traffic, construction work, and human activities. For our case study, we conducted the measurement at Block M UiTM Samarahan. We used a sound level meter SLM application to measure the noise level in a weighted decibel dBA using the light method. The purpose of this study to measure the environmental noise level at Block M and compare the result with the World Health Organization WHO noise guideline.
I will explain the equipment that we used during our case study. We used two main pieces of equipment, a tripod and a smartphone. First, the tripod was used to hold our smartphone in a stable position while taking photos and recording videos. This helped us capture clear and steady documentation throughout the site visit. Next, we used a smartphone which served multiple purposes. It was used to take photographs, record videos, document our observation, and measure sound level using sound level meter app. We also use the stopwatch function on the phone to measure the duration of specific observation and activities. Using the phone made our work more convenient because it combines several functions into one device. Finally, we use a sound level meter to measure the environment noise level at different locations around the site. The readings were recorded in decibels or dB, allowing us to assess the notes or condition and determine whether they were suitable for the surrounding environment. In conclusion, these two pieces of equipment were essential for collecting accurate data and documenting our findings. They helped ensure that our case study was carried out efficiently and that information we collected was reliable. Thank you.
I will explain the location of our noise measurement. Our case study was constructed at Block M, UiTM Sarawak Branch, Samarahan Campus 1. This location was chosen because it is a central area where students and staff usually work, relax, and gather. Besides that, students and staff always passing by using their transport, such as cars and motorcycles at Block M. Therefore, it is suitable for measuring the surrounding noise level. As shown in the location plan, Block M is located near the lecture halls and residential college, making it one of the busiest areas on campus. The measurement was carried on 25 June 2026 from 11:50 AM until 12:20 PM. During the measurement, the weather was sunny with light wind, which provided suitable conditions for collecting the noise data. That's all for the location of our case study. Thank you.
As you can see, this is our spot to take the measurement of noise level. For the first step, we would have to download the sound meter apps in the Google Play Store. After the download complete, you just need to open the apps. This application showcases the sound level meter, stop button, average, maximum decibel value, and the reset button. Now that we have discovered the first step, the next procedure will be to find a suitable location to conduct our sound level measurement. The first things we need to do is set up the measurement instrument, which is tripod that can hold our mobile phone while conducting measurement of noise level. Then, start up the sound meter apps and start measuring the sound level. At the same time, don't forget to set a 1-minute timer to keep a track.
Example of car noise interference. This video shows a car passing by near our recording area. Vehicles sound like this were one of the main sources of noise interference during our measurement, as the location is close to the main road and car park. Example of human activity interference. This video shows student and lecturer walking and talking near Block M while we were recording. Since this a busy walkway connecting students to nearby buildings, their conversation and footsteps were a major contributor to the noise readings we captured.
Next, I will present the results of our noise level measurement. This table shows the sound pressure level or SPL recorded every 1 minute over a 30-minute period. The readings are measured in decibels or dB, and the last column shows the possible source of the sound during each measurement. Based on the table, the recorded noise level range from 40.1 decibel to 80.3 decibel. The highest reading was 80.3 decibel at 12:10 p.m., which indicates a sudden increase in noise because of the car passing by playing loud music. The second highest reading was 71.4 decibel at 11:50 a.m. when a motorcycle passed by. Most of the readings are between 50 and 65 decibel, showing a moderate noise level throughout the measurement period. From the remarks column, we can see that the main source of the noise were cars passing by, motorcycles, people walking, people talking, and bicycles. Among these cars passing by were the most frequent source of sound, followed by the people walking. There were also a few lower readings such as 40.1 decibel at 12:13 p.m. and 41.0 decibel at 12:18 p.m. These lower values suggest that there were less activity during those times. To evaluate our results, we compared the measured sound pressure level or LAEQ with the noise guidelines recommended by the World Health Organization or WHO. According to the WHO, the recommended outdoor noise level for places such as school, playground, and public outdoor areas is around 55 decibel LAEQ. From our measurement, most of the recorded sound level were between 50 and 65 decibel. This means that the noise level was generally close to the recommendation limit. However, there were several readings above 55 decibel, especially when cars and motorcycles passed by or when people were talking and walking nearby. The highest reading recorded was 80.3 decibel, which was much higher than the recommended level. However, this was only a temporary increase caused by surrounding activities and does not represent the normal background noise throughout the whole measurement period. The lowest reading was 40.1 decibel, showing that the environment became much quieter when there were fewer people and vehicles. Overall, our findings show that the noise level was mostly moderate, but it increased whenever there was more human activity or traffic. Therefore, the measured noise level was generally acceptable, although some short periods exceeded the WHO recommendation due to the temporary noise source. That concludes the discussion and findings section.
In conclusion, this study successfully measured the environmental noise level in Block M using a sound level meter. The results showed that the noise level was mainly influenced by students' activities and nearby vehicle traffic. By comparing the measured noise level with the WHO guideline, we were able to evaluate the noise condition at the study area. Overall, the study highlights the importance of monitoring noise pollution to create a safer, healthier, and more comfortable environment to everyone. That's all. Thank you.